Chapter 6, Section 4, we have a couple of special systems, and we can solve these any way we choose. So looking at this first one, I'm going to use substitution, and I'm going to put that whole thing in place of the y. And that will become 3x minus y equals negative 2. And you'll notice in place of the y, I put those parentheses. And we're going to put that 3x plus 2 in there. You need to distribute this to the whole thing. So we have a negative 3x and a negative 2. 3x minus 3x is 0. So you have negative 2 equals negative 2. That is a true statement. It's always going to be a true statement. So that is going to have an infinite number of solutions, all real numbers. Any number that you put in there will make that true. Letter B, we're going to take this and put it in place of the y. So that will become a 2x plus a negative 2x plus 5 equals 1. 2x minus 2x cancels, and you have a 5 equals 1. It's not true. It's never going to be true. So for this one, there are no solutions. And if you prefer, you can put empty set. This next one, just trying to think of a good way to do it. I guess I'm going to divide everything by 3. And we're going to have some fractions here. So that would become 6x plus 7. And we're going to put this in place of the y. That will be a negative 2 thirds x plus 8 thirds equals 10. So this will be 6x plus a negative 14 thirds x plus 56 thirds equals 10. And I'm going to change that negative 14 thirds into a decimal. So this becomes 6x plus a negative 4.6 repeating x and that becomes 1.3 repeating x. This 56 divided by 3 is 18.6 repeating, and so I'm going to subtract that from both sides. 10 minus 18.6 repeating is a negative 8.6 repeating. And then what we're going to have to do is divide both sides by 1.3 repeating. And if you believe this, you end up with x equals negative 6.5. Now those are some pretty nasty fractions if you didn't follow that one. That one's just a normal one where you find 1 point as your solution, and we could substitute this in. 6 times negative 6.5 plus 7y equals 10. 6 times 6.5 is 39. And negative 39. So if you add 39 to both sides, apologize, I'm running out of room here, you will have 7y equals 49 and y equals 7. And other than some nasty fractions, that's just like we did the previous 2 days. Letter D, And take this and put it in place of the y. So you will have 2x minus 3 times 2/3 x equals 6. Negative 3 times 2 is negative 6. Divided by 3 is 2x. So we end up with 0 equals 6. That's not a true statement, so there are no solutions. This one, I'm going to set them equal to each other. So negative 2 times x minus 1 equals a negative x plus 3. That becomes a negative 2x plus 2 equals a negative x plus 3. We're going to add 2x to both sides. Subtract 3 from both sides. And x equals negative 1. And substituting back in, I'm going to put it into this one. Negative 1 is a positive 1 plus 3, and our y will equal 4. We're going to skip example F and go on to the story problem. Matt has $100 and deposits $20 per month. Ben has $80 and deposits $20 per month. Will the accounts ever have the same balance? And if you look at that, you subtract 20x from both sides, you end up with 100 equals 80, which means there is no solution. And I'm guessing there are several of you who could have just looked at that and said, one guy starts with 100, the one guy starts with 80. Of course, they're never going to have the same amount, but I wanted to show you mathematically what happens there.